does not give you the formula I'm about to give you.
Yeah, I've been looking at that.
The formula I'm about to give you, if you look up binomial distribution, this is the one you'll find online. Right? It'll typically come in 1 or 2 presentations. It'll either be represented as
Oh my god.
that one, right? It'll look like that. Or that's essentially equivalent to. Does anybody recognize this formatting, by the way? Notice there's no fraction there. Right? This for in the parentheses, you have a single letter over another letter like this, N over R. This is N choose R. Right? Basic combinatorics. N choose R, P to the R times
R.
Q to the N minus R. And when you put parentheses around that. So Q to the exponent of N minus R.
What does N choose R means in a calculator?
That's on the calculator.
I don't have exclamation marks on my calculator.
Yes, you do.
Where is that?
Do we know what the exclamation mark means?
Yeah.
You've probably seen that before.
Factorial.
It's a factorial. I guarantee you that's on a more expensive calculator. Did you find it?
Is it on the 99-cent calculator?
I got it.
All right. If you want, you won't find this. I'll give you one more variation. That's the one I like. If I take this one, if I say N factorial, and I modify it slightly, I got R factorial times N minus R factorial. Put a summation sign in front of it. I increment the summation sign from the bottom, R equals 0, which is the number of successes, so 0 successes, up to number of trials, N. Right? What's that equal to?
1.
Right? I like that variation of 1 in the first one. You won't find this one online, but I think that's probably the best representation of this whole thing. If I were to ever get a tattoo,
Oh
it'd be
my
that.
god. For real?
For real, that's my favorite mathematical equation.
What is, okay, now you would get that?
That's the binomial distribution equation, right?
Be a question on the test?
No.
What tattoo would Dr. Ruther get?
That is my single favorite equation across any mathematical formula.
Why?
That'd be an extra.
Because of the applications, because of the symmetry, because of the math involved, because of the discrete nature
Where
of
would
the
you get that?
Do what?
Like, where would you get it?
What do you mean?
Your cat.
Oh, got a tattoo place?
No, like, where off your mind?
Like, I want to get a big honeycomb right here with a big bumblebee coming up my neck.
All right.
Like, where would you get it at?
I don't know, probably my shoulder.
Okay. Get it.
Oh my gosh, that'd be so funny. You should.
I get it on my ear, really small.
Yeah. He's about to ever
You
get a
have to be
tattoo.
careful about tattoos in the ears because they do come off after. They can come off.
Do you have tattoos?
He said that
Do
would
you
be his
have
first.
tattoos?
He's got one.
No?
You don't have any?
No, he said that was
I
be
thought you
his
said you
first.
did.
No,
Wow.
I don't have any tattoos.
Oh, I thought you said
You
you
were a
did.
good child.
I've got a number of scars.
Oh. Hey,
All
you're
right.
still young. My grandmother was 75 when she got her first tattoo.
Notice
Oh my gosh.
this number, N choose R, which is the same thing as this part over here, right? That is essentially going to give you the coefficient number in front of every single value over here. Every single value over here, notice has a P to some exponent and a Q to some exponent, coefficient. So essentially this is in the format of X, P, let's say Y, Q, Z. Coefficient, exponent, exponent, PQ. There's my P and my Q. There's an exponent. There's an exponent. Here's the coefficient. Right? Effectively, I can take, well, simple. If I'm building this, right, this is N1, N2, N3, N4, N5, N6, N7, right? If I ask you, let's say, what's the probability of flipping 5 heads in 7 trials? Right? 7 trials, N equals 7. Choose this equation, right? 5 heads, 5 successes, right? Then you plug in values. 21 times P to the 5th, Q squared. If I plug in 21, probability of a head is 0.5 to the 5th power times 0.5 squared. Multiply that out, that's probably getting 5 heads and 7 trials. Right? This is the probability of 7 heads and 7, 6 heads and 7, 5 heads and 7, 4 heads and 7, 3, 2, 1, 0 heads and 7. Right? Does that make sense? You can build the expansion that way, and that works perfectly well. Right? We'll plot numbers off of P and Q equal to each other in a second. But if you don't know what the specific expansion is that way, so if I said something, what's the probability of, let's do a slightly different example. Let's go off the 0.5. Suppose I have something like my 8-sided die over there. I've got an 8-sided die over there. Right? I'm rolling the 8-sided die multiple times. Right? On any given roll of that die, I call a success either a 1 or a 2. Right? So if I roll the 8-sided die, rolling either probability, what's the probability of a 1 or a 2 on an 8-sided die is equal to the probability of the 1 plus the probability of the 2 on the 8-sided die. Right? What's the probability of rolling a 1 on an 8-sided die? 1 and 8. What's the probability of rolling a 2 on the 8-sided die? 1 and 8. So this becomes 0.25. 1/8 plus 1/8, which is 2/8, which is 1/4, which is 0.25. Right? What's the probability of not rolling a 1 or a 2 on a 6-sided die? 0.75. 1 minus this. So if I call this P and 0.75 Q, that's success, that's failure. And then ask the question, what's the probability on an 8-sided die of rolling 6 successes listed as a 1 or a 2, on 12 trials? So N here is now 12. Right? Let's say, what's the probability of 6 success in 12 where success is 1 or 2 on 8-sided? Right? In order to solve any of these problems, right, at this point, any of these problems, you need 3 pieces of information. Right? You come across the binomial distribution. If you want to know, do I use the binomial distribution, you have to have at least 3 pieces of information. Right? From those 3, you can calculate others. Right? 3 pieces of information here. First of all, what is the number of trials? All right? So you need, let me get rid of this for a second, come back to it. You need N. Number of trials. That's one thing you need. Right? You need R. Number of successes. Whatever I'm calling a success. So you need N, value of N. You need R. Okay? You also need the probability on any single trial of a success. Notice the assumptions behind the binomial is this probability does not change across trials. So if you know it for one trial, you know it for all trials. Right? Probability here we're going to call P. Just like that over there, P is probability of success. If you know P, you automatically know Q. Right? Probability of success, because they're mutually exclusive and mutually exhaustive, probability of success is 0.25, Q must be 0.75. If the probability of P is 0.33, the probability of Q is 0.67. Probability of P is 0.5, probability of Q is 0.5. The probability of P is 0.4, the probability of Q is 0.6. Right? If you know P, you know Q. Right? If you know the number of successes, you also know the number of failures. If I have 6 successes in 12 trials, how many failures must I have? 6. 6 successes. The remaining 6 must add up to 12. Give me a total trial of 12. If I have 8 successes in 12 trials, I've got 4 failures out of those 12. Right? It's one of the reasons I like this particular equation. It's symmetrical on multiple levels. It's symmetrical both in its probabilities and distributions, and it's symmetrical in terms of the number of the outcomes. Right? Got a lot of symmetry built into this particular formula. If you know P, you automatically know Q. If you know R, you automatically know N minus R. Right? Because R plus N minus R must equal N. Right? So now I just gave you 6 number of successes. That's this one. 12. That's this one. Right? Probability of success. 1 or 2 we just said was 0.25. That's this one. I got 0.25, 6, 12. Okay? Make sense?
Mm-hmm.
What I don't have over here is the 12th expansion.
Mm-hmm.
Right? If I got down to the 12th expansion, right? Calculate all the down, you can make up all the expansions, you can work them all out, get all the coefficients, put in all the exponents, right? You can do that, or if you wanted to, you can jump straight to this formula up here. Every one of these terms in all these equations comes directly from this formula. And from this formula, we can just plug in some terms, plug in some values. So I'll get rid of this, because I'm going to come back to this expansion in a second. All right, so let's go over here. Let's go with the n choose r. N was equal to 12. R was equal to 6. Probability of success, 0.25. Right? Plug that in for P. Right? Notice P is to the R power. So 0.25 is to the 6 power. Right? Q is always 1 minus P. So Q must be 0.75 here. So we got 0.25. 0.75 is Q, and my P and my Q value. The exponent for the Q value is equal to n minus r, 12 minus 6, in this case, it's also 6. Right? And now just calculate that. Right? The one little quirk you have not had yet, I'll introduce here is the factorial. The 12 choose 6. 12 choose 6. Let me get rid of a little bit of space here. The 12 choose 6 sets up as 12 factorial over 6 factorial times 6 factorial, where n minus r is 12 minus 6, that's 6 factorial here. All right? So who knows how to do a factorial?
6 times 5 times 4 times 3 times.
Take whatever the number is and multiply by every discrete value, whole counting number, down. So 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. Not 0, so multiply by 0, everything collapses, becomes 0. Right? 12 factorial is 12 times 11 times 10 times 9 times 8 times 6 times 7, all the way down to 1. Right? So this will expand then as
924.
12 times 11 times 10 times 9 times 8 times 7. I'll leave it there for a second. Denominator, 6 times 5 times 4 times 3 times 2 times 1. But I got that twice. Right? But notice I got 6, 5, 4, 3, 2, 1. And I got 7, 6, 5, 4, 3, 2, 1. This part, 6 down to 1. I can cancel with one of these. These are actually way simpler than they first appear. Right? Because there's a lot of canceling involved. Likewise, if I got a 12 here, in the numerator, and a 6 here, I can get rid of that 6 and make that a 2. And I can get rid of this 5 and make that a 2. And I can get rid of this 4 and make the 8 a 2. And I can get rid of the 3 and make the 9 a 3. And I can get rid of the 2, and let's say I get rid of one of these 2's, which leaves me in the numerator 2 times 11 times 2 times 3 times 7. Right?
That's right.
I don't have
I got 924.
I bet if I multiply the 2 times the 11 times the 2 times the 3 times the 7, I'll probably get 924. Let's see. 2 times 11 times 2 times 3 times 7, 924.
What if I don't have the exclamation point in my calculator?
You do it this way.
Calculating
It's
Or you
way
go
simpler
buy a
than the first
calculator.
period.
Pure B. And it's a good option.
What do I do?
Look at the numbers.
Oh my gosh,
Here,
you're the
what?
best.
Show me, sis.
Factorial should be on any relatively expensive calculator.
PRB.
Let
And it's
me be
right
right back. Oh,
PRB.
PRB. Oh,
See, now I got
okay.
924.
Yeah. And she needs to have a number in front
25 to the 6th power.
Wait, what do I do now?
Here's a shorthand for you if you're not familiar with it.
Wait, if it's 12 factorial, 6 factorial, tell me again why you got 2 6's at the bottom?
Let me do a slide.
At the top.
I love that
Why
movie.
would it be 1 6?
Because
Suppose instead of saying what's the probability of 6 in 12, suppose I say what's the probability of 10 in 12. Right? Read the concept. If I have,
10,
instead of
10,
12 choose 6, I've got 12
and 12.
choose 10. That's equal to 12 factorial over 10 factorial times 2 factorial. Right?
To make 12. you're trying to
10
make,
plus 2 equals 12, that's what you get over here in terms of the n r factorial times n minus r factorial.
and so with the
So
12, when it was 12, you did the 6 plus 6
If it's
gives you
12 factorial,
Okay.
that's 12 times 11 times 10 times 9 times 8 times 7 times 6, 5, 4, 3, 2, 1, right? That's the numerator. The denominator is 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 times 2 times 1, right? But look how that cancels, okay? 10, 12, 11, 10. From 10 down to 1, that part of the equation is exactly for this part of the equation. This cancels with this. And that leaves me 2 times 1 into 12 times. I can take 12, make it a 6, get rid of the 2. Now I've got 66 over 1, which is 66. It's way easier than it looks. Right? There's a lot of canceling you can do here. Simplify the factorials almost immediately in these equations. Which is another reason I like them. Right? You can do this kind of thing in your head. Right? If I had the original 12 choose 6, that's 12 factorial. But I can take half of that, because I got 6 factorial here, times the 6 factorial here, and just cross it off. Right? That leaves me the 12 times 11 times 10 times 9 times 8 times 7 divided by 6, 5, 4, 3, 2, 1.
Now, like, what would be
That
an
was what it
example problem like on the exam is coming?
Just like this, let's probably 6 successes in 12 trials. And as I pointed out, we said 12 choose 6 was 924 times 0.25 to the 6th power times 0.75 to the 6th power, right? 0.25
Okay, so
to the
that would
6th
be the
power.
question. What percent of 6 success is 12?
0.0002.
Where success is bad.
0.75.
What does that say? 8 to SL. Period. Honey, I cannot read that. So that's the question. So that's it.
I'll repeat the question in a second. Let me do this.
Yes, sir.
I get a value of 0.0328. Now, what you're asking. The
Yes.
question was, what is the probability of 6 successes in 12 trials, where a success is a 1 or a 2 on an 8-sided die? A 1 or a 2 has a probability of 25%. So I've got number of trials is 12, number of successes is 6, probability of success is 0.25.
Got you.
Plug directly into this equation, 12 factorial or 6 factorial times 6 factorial times 0.25 to the 6th power times 0.75.
So that question will be on the exam. I mean, that formula will be like this.
I'll
is
give you
the
this one,
formula.
but I'll probably give you this expansion.
Oh, okay.
I'll give you this expansion up to at least 7, if not 8.
Alright.
And there'll be a slightly easier way to do it.'t
It's like a Christmas tree.
I think so.
Yeah.
It's just a gift from the match job.
Yeah. Oh, love it. Thanks.
He don't believe in Christmas.
Bah humbug.
You leave in Hanukkah?
I rebuke that. What you just say to me?
Bottom
Ebenezer Scrooge was?
Yes. I love that.
Not a real person, pictorial picture.
Well, that would be you though if it was real. Like you would be that.
No.
I'm more of a Jacob Marley
Who?
How was
person.
Edward
Ebenezer Scrooge, he was just mean and angry.
Oh.
He hated life and he hated Christmas.
He has
and
a really
spirit.
good life.
Like
Yeah.
visited by 3
Is
ghosts.
that like Krampus?
Yeah,
Like
he was
he-
visited by the 3 ghosts of the Christmas.
Krampus is
He's
freaky.
like Krampus, no.
No,
You
that
said Krampus.
Think about it. Think about it. By next
that's
week,
the that's the
Krampus. He's scary. ain't
Krampus.
he?
Krampus.
Krampus.
Krampus?
Yeah.
Yeah, I seen Krampus or Krampus, whatever, on that movie, the red one.
Yes.
I love that movie.
I can
The
only-
red
I'll
one?
bring it back around from last week's
That's
discussion in class, right?
Krampus.
We talked a little miniature. I've got a miniature of Krampus.
I knew it.
I love
I've got a little
it.
1-inch tall miniature of Krampus.
You like him.
Okay.
It's
Tell my
promotional
dad all
here.
the
It's,
You
time.
said
it's
you
really
like
hard to
him.
find. It's
Your
really hard to
favorite is the
find.
Grinch, huh?
My dad
Go
gets
Grinch.
really grumpy.
Go Grinch, he said.
All right, so let's go back to
Is
the
he,
equation.
is he grumpy?
Yes. Like a person.
My husband tries to be grumpy.
We're
I
gonna
don't
get rid of
him.
stuff over here.
I don't mess with him like that.
Let's leave that up for
I
now.
don't play.
All right, so ask some more questions. We'll around the room here and try to get some answers and figure these out. I'm only going to use up to the 7th expansion, right? But for the sake of argument, right, we're going to modify this slightly. Instead of rolling a 6-sided die, or instead of flipping a coin, instead of rolling an 8-sided die or flipping a coin, suppose I start rolling a 6-sided die, right? So I'm using a regular 6-sided die. Right? And I say, what is the probability of rolling, how about a let's say, what's probably rolling a 6 on 2 out of 7 trials? Say what is the probability of a 6, I'll put it in parentheses because that's the outcome I'm looking for, on, I say 2 of 7 trials. Do I have the minimum necessary pieces of knowledge to solve a binomial expansion? Solve a binomial equation.
Okay, now what now?
I say, what's the probability of rolling a 6 on 2 of 7 trials?
Okay, so here we go.
This is 2, so if we
We'll start at the bottom right over there. What is the number of trials?
2.
No. 7. Number of trials is total number of trials. What is the number of successes?
Okay.
2.
2.
Okay.
What is the
2 of 7.
probability of a success? Oh yeah, I'll write it up from right there. Number of trials is 7, number of successes is 2. What's the probability of a success? 0.17. If I round it up to 2, it's 0.1666 repeating,
Okay.
right?
Wait, and why would it be that? The probability of success is what? 1 out of 6, okay.
How many ways on a 6-sided die can I roll 6?
1.
1,
Okay. I'm tracking.
right? So, let's go back here, Lily. Which expansion do I want to use?
Last one?
The last one, n equals 7, because n equals 7 over there. Okay? Dina, which term across that expansion am I going to use?
The second one?
This one?
No. I don't know.
You're close. Coming at it the other way.
The
If the number of successes is 2, which exponent must equal 2? The exponent on the p or the exponent on the q?
P.
P. If p is to the second power, I want that term,
Okay.
right?
Alright.
If I've got 2 successes in 7 trials, how many failures do I have in 7 trials?
Now that.
Say it out loud.
5.
5. If p squared, q is 5. P is a success, q is a failure. Right? What am I calling a failure?
Tails. I mean,
No.
not the
Anything
5,
that's
3, 4, 5, everything. that's
Either
not-
a 1 or 2 or 3 or 4 or 5.
Right.
If I have either 1 or 2 or 3 or 4 or 5, what's the probability of q? If I know the probability of p, what's the probability of q?
Like as far as.
If I know p is equal to 0.717, it's 5 out of 6. The problem q here, this is p,
Okay.
q must equal then 0.83,
Okay,
which
now-
is 5 out of 6.
Q, okay, 0.83 equals 5 out of 6. But why does that not have nothing behind it?
Those two values must sum to 1.
Okay, but why didn't you have write anything behind it?
What do you mean?
Like you have
Over
NRP
here?
written down, yeah, will there be anything written behind all that?
Q equals the probability
Right.
of a failure.
Okay. Gotcha.
Right? If you know one of these, you automatically know the other,
Right.
Yep.
right? If
Gotcha.
you know the number of successes, you know the number of failures. If you know R, you automatically also know N minus R. Does that make sense?
Yep.
So now I got number of trials 7. I got the probability of success. I got the probability of failure. I've got the number of each one of those in terms of number of successes, number of failures. I go to this term, right? And I take 21 times 0.17 squared times 0.83 to the 5th, right? And I multiply that across, and that will give me the probability of rolling a 6 2 times out of 7.
Yeah, but
You do
sometimes
math
whenever
over there.
that gets posted up there like that, I've gotta have like a legitimate reason next to it.
Oops.
You see what I'm saying? To follow with
Did you
it.
say whoops?
Honey, I would say whoops too with that preschool calculator,
no, I-
sir.
That's all you need.
That's what they used to give me back in the day, I remember.
2390.
Yes, but I have trouble with learning, like, sometimes whenever it comes to just like that with nothing with it. You see what I'm saying? To let me know what that is.
I have 2
Cause I'm a visual person too.
So the question is, what is the probability of rolling a 6 on a
On
two?
On 2 out of 7
On
total
two,
tries.
on 2 tries out of 7, on 2 rolls.
Rolling a 6 on 2 of 7. There are 21 ways that combination can fall out,
Okay.
right?
Like
I can
on
roll
2 of
6,
7
6,
rolls,
and then
right?
a bunch of 5s. I can roll a 6 and a 1 and a 6 and a bunch of other numbers, right? There are 21 ways I can roll only 2 6s and exactly 2 6s.
So if you know the first number, you know what the exponent of P is, and you can probably find the equation that way, right?
What do you mean by the first number there?
Like, okay, so 2 out of 7, so if you know 2, you would know, and you know 7, so you would know which line you would use, and then you would know to go over and.
If you know
21,
total number of
22.
trials, that tells you what equation you're using. If you know number of successes, that tells you which term in the equation to use,
Yeah, that's what I mean.
right? Once you know which term it is, then it's just a matter of plugging in the probabilities, given the probability of a success on that particular trial. Right? So what's it, go ahead.
But then you can also use the formula there, the one we just did on the prior example.
Formula there,
Yes.
With the
7.
exclamations.
choose 2 times p squared, give the fifth. This, right, will give you this piece of the equation. The 7 choose 2 will give you 21.
Okay.
Right? You've already got the p squared q to the fifth, right? It's the exact same piece as this. I just haven't worked out the 21 from over here yet. 7 factorial, 7 times 6 times 5 times 4 times 3 times 2 times 1
Thank you, baby.
divided by 2 times 1
Thank you.
times 5 times 4 times 3 times 2 times 1. 5, 4, 3, 2, 1 cancels. Right? The 2 cancels with the 6. There's a 3.
21.
7 times 3 is 21. Guess what?
Ah, okay, that makes more sense.
So that's just to get that number though. It's
That's
not
the
to
number
get-
of ways the combination can express.
Alright,
But the neat thing about it is these are relatively low numbers, right? If I said, what's the probability of, or I'm gonna say, how many different ways, right, can I have, let's say, 55 successes out of 75 trials?
55.
That'd be 75 factorial divided by 55 factorial times 20 factorial. All right, it's gonna be in the thousands. All right?
You said it'd be 75
But you can calculate it.
factorial? Over 50.
You're not gonna see anything that big in this class. You're not saying that. Don't be scared of big numbers, right? The patterning works the same.
It says overflow error.
All right, so let me give you a different one. Get rid of these. Get rid of this. Get rid of all this stuff.
Oh, I can't see.
And we're still using a 6-sided die. So I said, what's the probability of rolling either? How about a 4 or a 5 on 5 of 6 trials? Or rolling either a 4 or 5 on 5 out of 6 trials.
Or means to multiply. Not
No.
anymore though, huh? I know.
Or don't.
That was the add.
Or does not mean to multiply.
It's the add.
Or
it's
it's
the
to
addition.
add. It is.
It's the addition rule.
Show is. See, I'm trying to be funny just.
So I left it on the board. All right, so first question, Kenzie, all right, which distribution am I using? Hmm?
The second one from the bottom?
This one. Okay.
Quick question. Does that 6 mean that's 5 number of successes out of 6 rolls? On
This
the
is
dice.
5 successes out of 6 rolls, yes.
Okay. I have to make it literal.
So for that expansion, the second one from the bottom, right, which term from that equation am I using?
6P,
Mhm.
5Q.
First one? I mean the second and the sixth. This one.
Mm-hmm.
Right, I want 5 successes, p to the 5th. That's 5 successes here. That's this term. Right?
So then we pick this one.
What is the probability of a success?
4.
Wait, what?
So it'd
Calling
be
a success either a 4 or a 5. What's the probability of rolling a 4 or a 5 on a 6-sided die?
0.33.
1/3, 0.33. Right? Once you know the probability of success, number of successes, number of trials, that's my NRP. I also know Q. What's Q?
0.66. Originally 0.67.
I'd go 0.67. If you're doing 0.33, I'd go 0.67. But it's not gonna bother me if I say 0.33 and you say 0.66, because they're close enough. Yeah. Right.
0.833.
So I get
6.7.
6 times 0.33 to the fifth times 0.67 to the first. Took this term, right down here. 6, probability is 0.33. Fifth power, Q's failure, 0.67. First power, multiply that.
I got
Okay, now.
0.33 and 0.167.
I have no idea where you got 0.167.
Yeah, that's a little
Because you do
struggle.
5 out of 6 to get your decimals.
Geez.
If your probability of a success is 0.33, your probability of failure is 1 minus 0.33, which is 0.67. Right? So doing the multiplication there.
Yes.
Because I thought we were going like 5 out of 6.
I get a value of 0.0157. Important factor here is everybody see how I told this particular piece of the equation from the specific equation.
No, I'd like to go over that one more time.
Look at the exponent, right? The exponent for your p-value is your number of successes. That's the thing, R, right? R is your number of successes. That's gonna be this value if you wanna calculate it out, right? It'll be given to you in the problem. In order to use binomial problem, you must know the number of successes, you must know the number of trials, you must know the probability of a success. If you know the probability of a success, you automatically can calculate the probability of failure.
How many more homeworks do we have?
3 total, 1 tonight, 2 more next week's.
Oh, okay.
This okay?
Yeah.
So I'll make it easier for you.
It's gonna be a little bit of a struggle again.
Slightly easier, not entirely.
Just a little bit. Miss Robin needs explanation one more time.
I'm still
I
trying to figure out how you know that.
I
Tell
call
her.
a success either a 4 or a 5. The probability of the 4 is 1/6.
Okay,
The
so
probability
I
of
can't
5 is
read your
1/6.
handwriting, basically.
Probability of 4 is 1/6. Probability of 5 is 1/6. 2/6 is 1/3, which is 0.33.
You got
I
it?
can't read your handwriting.
Okay.
How did he get that number?
Which one? So he pulled from the 6,
Bless
right?
you.
Thank you.
And then a 4 or a 5, so that's 2 out of 6 on the dice.
I was thinking.
I'm confused.
It's worse than the whatchamacallit.
Why do we have another one of these? Oh my God, I'm done.
What I just gave out.
Yeah.
It's making us miserable.
This is a binomial distribution table, which has already pre-calculated for you a number of answers. Right? In order to read this table, I'm going to walk you through it. Once you understand it, this table is incredibly easy.
Okay.
Right? The table has limited applicability.
Okay.
Right? But
Let me get my highlighter out.
for the problems where it is applicable, it is very, very simple and very, very easy to use. Right? So here,
Okay,
Going
why
down
am I doing this?
Huh?
I mean, why am I having this?
this table will be an efficient way to calculate, instead of going up, say, 7 trials, I got on the board, distribution up to 7 trials and expansions. This goes to 20. Right? If you look at the bottom right-hand corner, I should start on the left.
Okay.
On the left, where it says number of P or Q events.
Okay,
Goes up to
Right?
16 actually.
got you.
Oh, the one in the textbook goes to 20.
What page?
Sorry. I've got a
Do we
two-page
need
handout.
that? Do
If
we
you want
need
the second,
that
I need the second.
extra
No.
to 20?
We'll be okay. All right, so look down the side where it says N. All right, very, very first column on the far left. N. 1, 2, 3, 4, 5, 6, 7. Right, got 8 on the first column. That essentially is going to give you all the values I got on the board here. Right? Middle big column. N starts at 9, goes down to 12 at the bottom. Right? And then the next one starts 13, goes to 16. For each addition on the trials, going from 1 to 2 to 3 to 4 up to say 16, notice you got 1 extra term in the equation, which is why the table gets bigger and bigger and bigger as it expands. Right? If I got n equals 7, there are 8 terms in the equation. So for n equals 9, there are 10 terms in the equation. For for n equals 13, there are 14 terms in the equation. Then you go to the
Hey,
second
why are you
column.
saying 14?
If n equals 13
There's
as
a
trials, there
zero.
are 14 terms.
I only see 13
There's a
terms.
zero.
It's a zero.
Oh, okay, I see it. I'm sorry. Got it.
The second one, number of P or Q events, that's the number of successes or failures.
Okay.
If you only have one trial, you can have 0 successes or 1 success. There are only 2 outcomes,
Okay.
right? That gives you the outcomes going from, for 2 trials, 0 to 2.
Now show me an example, like how you would use, like what
We're
we
going
would
to in a
use.
second.
Okay.
Then you go to the middle block of the table, right?
Okay.
It says P or Q, right?
Yeah.
These are in multiples of 5%, 0.05.
All right.
If the probability of a success, here, P, is a multiple of 5%, you can use this table. It's a multiple of 5%, you can use this table. So if I said, let's just take some numbers, throw some numbers in, we're going to cross-reference table. Suppose I'm doing something like flipping a coin, right? Flipping a coin is 50-50. 50.50 is a multiple of 5, right? It's represented by the last column, 0.50 here, right?
Okay.
If I say, what's the probability of flipping 10 heads in 14 trials? You know the number of trials is 14. Go to the 14 in the middle of the big block on the right. Right, 14 trials. I want 10 successes. Go to the 10 underneath that one, right? Read across the columns until I get to the probability of success is 0.50. Cross-reference the 0.50 versus the 10 and the 14, and you should get a value of 0.0611. So 6.11% is the probability of flipping 10 heads and 14 flips of a coin.
Really,
Right.
I like that.
Does that make sense?
Yeah, but why did you, okay, so why did you, because you said 0.5, where did that part come in?
Because 0.5 is 50-50 on heads tails.
Oh, got you, okay.
All right, so I'm going to give you a different set of kind of problem here. Suppose I've got
I'm ready to do this.
a jar of beads, right? Suppose I got a jar of beads, right? In that jar of beads, just to make the numbers nice and easy, right? I've got 100 total beads.
Like
Right.
beats, like,
Beads, like necklace beads, like
oh, beads.
Beads,
Oh,
like
you're
you
right.
toss them out for Mardi Gras.
Like beats.
Now, beads. Of those 100,
Yeah, right.
let's say 40 of them are red. We'll say 35 of them are blue, and the remaining 25 are yellow. Right? You got 100 total beads. I mix up the beads in the jar, the hat, whatever.
The beats.
Beads, the D.
Okay.
Right? I mix them up. I draw a bead randomly out of the jar. I look at its color. I put it back in, shuffle them up, draw another one. Right? Every single trial is independent of the other trials I'm using with replacement. Right? What is the probability of drawing 6 red beads in 8 trials? Let me go over here. Go here. We'll say 6 red in 8. Right?
Okay.
What's my number of trials?
Are you pointing at me?
Yep.
8.
8 is equal to n. What's the number of successes? Okay. 6 is equal to my number 6. I'll put a lowercase r. Right? What's the probability of drawing a red bead?
What's 0 full number? Oh,
You may have jumped ahead a little bit.
Wait.
Jasmine, what's the probability of a red bead? If there are 40 of them and 100 total beads, what's probably drawing out a red bead?
40 out of 100,
Which is 0.40.
0.40.
6.408. Is 0.40 a multiple of 5?
No. Yes.
Yes, it most definitely is. So I can use the table. The answer to that question is just cross-reference on the table. Nathan, what do I got as an answer?
Let me see here.
Clearly, surely you're not going to
I
get
need
this
to
on
walk
the
through this again. So, we start by going on the far left,
Right.
and we would go down to 8, correct?
Correct.
Okay. P or Q events, and then we would go to our number of P or Q events.
Which
So
was
that one's 6, right?
Correct.
Okay. And then we would go over to 0.40.
Correct.
So that is